So make sure you put the distractions away now, okay? For this unit, okay, at the top of this, on page 32, I want you to have on your study sheet a complementary scenario where complementary is when two angles make when an angle is a 90, you have a 90 there, and that could be cut by another line that cuts through it. The 90 is still there, but what this helps you with is if this is 40 degrees, okay, then you know that this is going to be 50 right away. If there's a 90, they add up to 90. Supplementary, on the other hand, I want you to think of a hat. Okay, a straight line is 180 degrees. So if you ever cut this, like in that scenario, you would cut it like that. If this is 30, then you know that this has to be 150 degrees. That's just a quick reminder on your study sheet. What is the difference between complementary and supplementary? Okay. I'm going to leave it at that for now. Okay, so here are the word problems. I'll do one or two examples, and then I'll ask you to try some on your own. So often you will encounter a problem that has angles seemingly outside the triangle. Okay? You should try to find a straight angle or a right angle to possibly find an angle. Your goal is to find an angle inside the triangle you're trying to deal with. Okay? So here's an example. Notice that they, most of the time, I've never seen it otherwise, they give you a description and they give you a diagram. So that makes it a lot easier, but you still have to know where the numbers go at times. The captain of a boat sees 2 points of land. So the boat is right here. There's the 2 points, right? Point C is 1.8 kilometer east of the boat. So, right, this would be east. A is at a bearing of 12 degrees. Okay, so this is what you're supposed to get out of that. Let's look on the side here. I'm not sure if they're going to throw this at you, but you need to know your bearings and your compass to a certain degree. So if you go bearings, anybody familiar with bearings? Yeah, some of us, yeah. So it starts, you would be at 0 degrees. If you're trying to go north, you would say 0 degree bearings, right? This would be 90. This would be 180. This would be 270. And when you're back, you're back to 360 technically up here. Okay, so 360 or 0. So, and another thing you need to know is that you've got your, I'll just do that here, compass rose. Put that on the side here as well. I hope you all remember your north-south. That should be pretty easy. And this is the one that students struggle with. Where does east go? Where does west go? I just tell my students, just think of it. It should spell we, not you. Right? You, don't have it that way. We. There we go. And I know you had the never eat soggy wieners and all kinds of interesting stuff in the past, whatever works for you. I'm not saying this is super important, but if it does show up, then you've been warned, okay? So if there's a bearings of 12 degrees, that means that if this is north, you're deviating 12 degrees towards the right, towards the east in this case. And there you have it, okay? And this is east right here. This is north. What angle does the north and the east line make when they meet? A right angle. There's a 90 right here. Okay? So there's a 90-degree angle formed between this line and that line. Okay? And why is that so helpful to us? Because we can figure out this part right here. Okay? We need an angle. You need an angle in here to get you started. So how will we get this angle here? We're just going to go 90, because we know there's a 90 here. We're going to take away 12 degrees. and you'll be left with 78 degrees. Okay, so angle B is 78 degrees in that case. Use a red pen, okay, or something to, right? Make sure you understand that we use the knowledge we have of complementary angles, knowing the fact that there's a 90, knowing the fact that this is 12, to get that 78. And now what do you have? We have a pair, correct? So what is this? This is sine law, right? So after this concept that I just taught you, the rest I would expect you to know how to do. I will do this with you just so we have a full example here. So copy this down, okay? And then we'll try to, what else is the question asking? I just rushed a little bit here. Slow down. What is this question asking us ultimately? How far is the boat from point A? That is our ultimate question. So we want to know how far is the boat from point A. This is what they want. So let's put an X there. That's the side length we're trying to solve for. Can we do that right now based on what we know here? Let me zoom out. Can we do it in one shot? Because we've got a pair. We've got this side length. This side length allows us to solve for that angle, right? So we need that angle because once we have this angle, we'll be able to solve for that angle and then we solve for that side. Okay, there's a lot going on here. So let's do that. Sine of A is across that side that you know. That's all you can do at the moment. Okay. So let's make this our step one. I put a step one here next to the 78. Then we started solving. And if you don't know how to get that answer that they're asking you for, just start solving for whatever you can. Okay. So let's find this out. Sine of A, cross, multiply, and divide. Let's plug that in. That's 0.704. Then I figure out the angle. So you go shift sine equals on my calculator 44.777. Okay, 44.77. That's not the answer yet. So I'm not going to circle it. I'm just going to say that is important. For those of you that are way back there, here it is for you guys. This was my second step. Okay. So maybe let's go right in our triangle here. 44.77 goes right there. Okay, that angle right there. And now that we know 2, we can find the third one right here. So let's do that next. This is my third step. Angle C is 180 minus 78 minus 44.77. That's 57.23. And important, but not the final answer yet. I will just give that a color if you're highlighting. I like to highlight that this, right, is our angle here. Because once you've got the angle across the side you want, bingo, right? You're very close to get to that. So 57.23 goes right there. And what would you like to use? You can use cosine law. You can use sine law. It's up to you. I will use sine law for this one. So I'm going to use the pair I already know as my fourth step here. Sine of 78 over 2.5 is equal to sine of 5723. I'll make an arrow go to that, right, to saying I solved it because I need it. And this is side x. Just a notation thing. Would this throw you off if instead of x I did this? Have you seen this in previous grades? Like it's telling you, I'm solving between A and B. Okay, so if that ever happens, don't let that throw you off. It's this segment between A and B. Should I leave it or what? I'll leave it as like this, just so you've seen it. If you go through your notes, you're not like, what is this, right? Consider it a variable. It's a variable, but that's how you state it. So here you go. Not angle, it's just side AB is when you multiply and divide. So 2.5 times sine of 57.23 divided by sine of 78. AB, aka x, right, is 2.15 kilometers. We're dealing with kilometers here. So that is my final answer. That's the one I'm going to circle. I'm going to clearly say that is what is answering the question ultimately. Were there a lot of steps? Yes. I would not deny that. Let's see, let's do one more here. Okay. When the exam comes, when the time for the exam prep comes, you're going to realize that questions usually don't have that many steps involved. Like this one we just did, there was a lot of stuff happening, right? I'm just doing that so you see an example that has like different pieces so you know how to use it in the future. So on the exam, I can put $100 down. They're not going to have a question that has this many steps all in one question. Find angle, find one other angle, right? And so forth. Like you're not going to have that many pieces. So if you feel a little overwhelmed, I'm just trying to prepare you for the unexpected, okay? Here, let's go and do this one here. So there's a weird part here as well. A ship travels south from a port, so you start here, travel straight south for 2 hours at 35 kilometers per hour. That is weird, okay? It then changes course and travels 20 degrees west of south for 3 hours at the same speed. So there's the 3 hour second stretch. How far is it from the port after 5 hours? And it says 5 hours because we traveled 2 hours this way and then 3 hours that way. So we're wanting to know how far are we directly from the port. So this is our unknown here, our ultimate goal. Okay? How do we deal with hours and speed? Because we only want side length, we want distance. Yes? We multiply, that's right. So if I ever throw this at you, just go 2 hours times 35 kilometers per hour. That means that this stretch you traveled 70 kilometers. Okay? So we can put 70 kilometers in here. Then you turn and you spend 3 hours on this stretch here, right? So you go 3 hours times, in this case, we're traveling at the same speed. Could have been that they changed the speed on us, but we're traveling at the same speed. Excuse the interruption. Yes, hi. Okay, so 3 hours times 35, that's 105 kilometers that you've traveled during that stretch. Okay, so we take the 105, we put that here. Let me ask you this. Can you start solving this? It looks like an SAS, right? But this angle is outside the triangle, right? If you're thinking of this triangle, the 20 is outside. What do you see? Do you see the 180 here? Do you see the hat? There's a straight line, and you can make a hat there, right? And that's 180. So we just want this stretch right here. Okay? So what would that be? 160, right? Because we know that this is 20, so this has to be 160. So I will show you the work here. I go 180 minus 20. That's 160 degrees. So the 160 goes in here. And now you have the SAS. After all this, after breaking down all this extra information that we've gotten, you use cosine law, right? SAS. Cosine law. So let's do this. X squared is equal to 105 squared plus 70 squared minus 2 times 105 times 70 times cosine of 160. Let me bring this down a bit. Next step is x is equal to square root. To give you a little bit of time, I'm going to type this in. I get 29,738.48153. Then I take the square root, and maybe you have to press the answer button. I'm not sure what your calculator is doing or what it needs. But this is what I get, 172.45 kilometers. So what's new, Mr. Erickson? What is new? Realizing that sometimes you have to do a little bit of extra work to get information inside the triangle. That's like number one. There's a 90, there's a 180. You have to figure it out. The other one is like some nuances, right? Some speed given and the time. You got to multiply that, right? And everything else, once you've got it set up, is sine law, cosine law, right? You just have to pick the right one. There's 15 minutes left. The only thing that I'm going to use this page to give you another case. I'm not going to solve it. Other scenarios. If you go underneath it. So let's say you have this tall building and just make the ground go off of it. And let's assume you're standing at a certain distance from the building and you look up to the top of that building. Okay. Let's assume you're like, you know what, I want to have a better look. I want to have a better look at that building. And you decide to move closer. And now you're looking up again. And let's say the question mentions that, what do we call this angle, by the way? Angle of? If it's horizontal going up like this, elevation, angle of elevation. Let's say they tell you that this is 50 degrees. What do you see? Do you see the straight angle here? I hope so. There's a straight angle right there. And this adds up to 180. You can do a hat like that. If this is 50, and remember, it's being created by this line that's cutting your straight line here. So if this is 50, then this is 130. Okay? So you've got, within the pink, you've got the 50 in here, and you've got the green here. Okay? So combined, they give you the 180. So there will be scenarios where you're going to have to use it, okay? So I'm going to say this, pages 34, I'm only going to assign 2 questions for now. 34 to 36, pages 34 to 36. See what you've got. There's not a whole lot of time left. If I do an AC tomorrow, it would just be basic, none of this yet. It'll just be sine law, cosine law, just to make sure we are on the right track.